All right. Excuse me. Well, we are at 10 o'clock. So what we'll do is we'll start getting ready to go. Sorry for any technical difficulties. Well, I just want to say thank you to everyone joining. My name is Eric Jones. I am the State Weed Management Extension Specialist here at South Dakota State University. And today, uh, despite the very long title of this presentation, I thought it would be good to talk pre-emergence herbicides and have a little bit of data with it, talking about, some ways we could potentially improve effectiveness, what's the repercussions of applying some of these pre-emergence herbicides at multiple applications on crop yield, because I talk about it so much, when I give a presentation or write a newsletter article, pre-emergence herbicides in today's day and age are quintessential, right? They're very critical. So, for me, it's kind of hard to talk about pre-emergence herbicides because it's not as clear cut as when you spray a post-emergence herbicide. For example, when you spray something like 2,4-D, you see those weeds curl up and okay, it's working. But there's a lot of different things that go into a pre-emergence herbicide being effective, right? You need to have that activating rain, right? You spray a pre, it sits on that soil surface, so if you don't have that precipitation to move it into the soil profile where these weeds are germinating, well, you're not going to get that effective control or management, if you will, compared to just spraying that post. But it's really an important topic as we move forward, right? We're limited on the amount of herbicides we can spray post due to, labels being revoked, herbicide resistance being a big one. So how can we really utilize these pre-emergence herbicides for our personal gain? Now I'm going to turn my camera off and we'll get into this real soon. All right. Now jumping into this, I think one of the biggest problems we have right now for weed management, just in general, not talking, herbicides or really anything, but the biggest challenge that I've seen and heard people talking about is keeping up. Now, farmers today compared to, even, 40 years ago, 30, 40 years ago, farmers are having bigger equipment. So it's easier to plant more acres than we can spray. So it's always that game of catch up, right? So you want to get as much acres planted, but you got to follow that up with spraying. And the more acres you have to spray, your time constraint. And with that, it's not just there's only 24 hours in the day, but a lot of the times those planters are going ahead of a rainstorm or something like that. So you may have a field, a section, whatever planted, but if you get a big rainstorm, then you're not going to be able to get in to put that pre on. So then you're playing catch up with a post. Excuse me. Didn't mean to do that. The other thing too is it's not just having this bigger equipment that can plant more acres. It's also these crops are getting planted earlier. And for me, what I think about, it's more soybeans that are getting planted earlier and earlier and earlier, and that can be good for a yield, but then again, it's just more of a time constraint because before, you would, I guess, historically, you would think corn's planted first, plant your corn, spray your corn, then you move to your soybean planting and spraying. But now it seems as if there's really no gap in between them and you're spraying both of these crops at the same time. And not so much a time constraint, but just the cost of farming today. It's really hard to justify spraying a lot of herbicides, a lot of different herbicides, multiple herbicides at multiple timings with low commodity prices. We're talking what, $3-ish corn, $8 soybean. It's hard to really justify some of these very expensive programs. But when we talk about this keeping up, I think one way we can kind of hedge our bets, if you will, from trying to play keep up is if we're adding these pre-emergent residual herbicides. If we're having those down, hopefully we can keep those weeds from emerging and not getting bottlenecked with trying to play catch up and spraying that post-emergence herbicides. Now, a question I get quite a bit is, all right, we spray a pre, how much residual activity do we get, on average? So we did a bare ground study this year when we sprayed 4 different herbicides, and these herbicides belong to the group 15 herbicides, and that'll be kind of a focus today because these herbicides can be used in most of the crops we plant here in South Dakota. They can be relatively cheap, and for the most part, they're effective. So getting into this residual activity, based on ideal conditions, so this was established right before rainfall. I think we had about a ½ inch of rain after we sprayed this, but we sprayed 4 different group 15 herbicides. We have Zidua, which is denoted by the black circle, Dual Magnum denoted by the white circle, Outlook denoted by the black triangle, and Warrant denoted by this white triangle. So if we've set up this graph here on the x-axis or on the bottom horizontal, we have the days application starting from right when we sprayed it, getting out to about a month and a half. On our x-axis or y-axis or our vertical axis, we have our percent control. Now, I don't really want to get into, looking at this different models, but if we look at these dotted vertical bars, this black bar is going to represent Zidua. So in order to get 80% residual activity, we're looking at about 42 days. Again, this is 1 year data, but about a month we're looking at. Dual Magnum was very similar at 38 days, same with Outlook, 37, and Warrant, we're looking at 29 days. Now, that's great, right? Again, we're getting several weeks of residual activity, but this is residual activity until we have 80% control. So we're losing that 20%, and now we're starting to have weeds come, right? And that's when we really are going to have to start spraying our post-emergence. We got to thinking, is there a little bit or something we can do outside of this herbicide in our spray nozzles to add a little bit more horsepower, right? It's good to have these several weeks of residual activity, but no matter what, it's never going to be a season-long pass. You're going to have to come back and spray a post eventually. But something that's always kind of made me curious was, what about nitrogen influence? So here we have 2 different insets. On the left, we have nitrogen only, and this is in soybeans, but the implications could be across all the crops here in South Dakota. And we have a bunch of weeds in there, and that's just nitrogen only. But if we look at nitrogen plus a pre, there's still some weeds, but the weeds are at a much lower density. And so for me, I'm thinking, what is that? Now, if we just think about seed physiology and how seeds germinate, nitrate, right? Part of the soil applied nitrogen, that's what helps plants grow. It is a known seed stimulant. So that gets me thinking, if we can stimulate weed seed germination and spray a pre-emergence herbicide, can we actually get a more effective kill? Because these pre-emergence herbicides are killing the germinating seeds, they're not ceasing this germination. So again, is it something we can do to add more horsepower to our pre-emergence herbicides? Now, on the flip side, what about post-emergence herbicide activity? Because if you look at a herbicide label that has any sort of language on it, most of them do, it says apply to weeds that are actively growing. Now, most plants are going to be growing better in a fertile environment. So could we have weeds being more susceptible in these fertile environments? So what we did was we conducted a little study here at Volga, just west of Brookings in 2023 and 2024. We did do this in soybeans, mostly to try to find another option to increase, again, our horsepower or effectiveness of our pre-emergence herbicides. But I think these implications could be moved to wheat, sunflower, and corn, obviously. But what we wanted to do is just see if there was a rate that actually stimulated the weed germination. Just trying to find that rate where we could apply a single rate to boost that germination. So we used UAN, urea ammonium nitrate. We use this because it's the most readily available source of nitrate. Again, the nitrate is what we're looking for to stimulate weed germination. And we applied this at 0, so non-treated, 5, 10, 25, and 50 pounds of nitrogen per acre. Along with that, we applied the nitrogen rate with and without dual magnum at a relatively high rate, again, because we're trying to see if we can increase our effectiveness with the various nitrogen rates. So if we can find that rate that stimulates germination, what happens when we spike it with that pre-emergence herbicide? Then following up, again, trying to see if these weeds are more susceptible in this nitrogen-rich environment. Liberty was sprayed when the weeds were about 4 to 6 inches in height. We did do this in soybeans. So what we wanted to see too is if, the specific goal wasn't to see if there was a yield bump, but if you can put something out that helps weed management, but also gives you a yield bump, I think that's probably going to be, quite favorable. Now, before we go into the results, I just want to paint this picture for you again of why we're doing this. Again, if you look at the inset that has the title of nitrogen only, we're seeing a lot of weeds in this soybean plot. But when we add that pre, the weeds are really substantially reduced. Now let's dig into the results a little bit. So first, we were looking at weed germination 21 days after planting and after the nitrogen pre-emergence herbicide application. Now, I will preface this at first. Water hemp was the predominant weed at this test site. So as I move forward talking about control and germination, this is all related to water hemp. Now, just to set up this graph, on the horizontal or x-axis, we have our nitrogen rate in pounds per acre. On the vertical axis or our y-axis, we have germination, and that is the percent of non-treated. So the non-treated would have no nitrogen and no pre-emergence herbicide. Now, if we look at this linear model, we're using this linear model just to try to tease out what rate actually influences this water hemp germination. Now we have two different lines. The white circles with the solid line is nitrogen only. And then on the below that, we have the black circles and dashed line, and that's the nitrogen with the dual. Now, shockingly, if we look at this top line with the open circles, we can see this line steadily increasing as we move from 0 pounds of nitrogen up to 50 pounds. So we're looking at, again, 100% germination of the non-treated to over 200% germination with just nitrogen alone. And looking at the slope of this line, there was almost a 2% increase of water hemp germination per pound of nitrogen. So obviously, nitrogen is stimulating water hemp germination at quite a decent amount. Unfortunately, when we did, I guess probably not unfortunately, but when we added the dual magnum, there was really no difference from no nitrogen to 50 pounds. So again, there's still utility in this, adding this dual, but you're not going to see germination completely reduced compared to just dual alone with no nitrogen. Now let's move on to pre-emergence control. Again, this graph is going to be set up very similar, but now on vertical or y-axis. We just have percent control of the water hemp after we sprayed this, again, with Liberty 21 days after treatment. Same thing with our lines. The white circles are just nitrogen. The black circles are plots that had dual and the nitrogen. And we didn't really see any increase of susceptibility with dual with nitrogen or nitrogen alone. But what I do want to point out is if you look at this 50 pounds, we did see a separation of control. So what this tells me is while you may not see increased susceptibility, you're going to probably have less water hemp plants when you add the dual because there was just less plants that germinated. So your control actually looks better, right? Rather than just trying to rely on that post-emergence herbicide. Again, having an effective weed management plan, 2-pass program, pre and post. Now, moving on to yield. So again, graphs set up very similarly. We have now yield on the vertical axis or y-axis. And this is not in bushels per acre, but this is just percent of our non-treated. Again, the plots that got no nitrogen and no herbicides. So if we look at just nitrogen only, there was a slight increase in yield as we increased our nitrogen rate, but it was always lower than the plots that had the pre-emergence herbicide. Again, early season competition, we have that weed interference, starting at V2, V3, when we have weeds, that's when we start seeing a yield decrease. So again, this really bolsters the fact that, we need that pre and the post. We can't just rely on a post-emergence application. So, it's a little weird doing this in soybeans, but what are the implications? So even if we aren't seeing a yield increase, what happens when we do put down soil applied nitrogen? Well, what we saw, at least in the case of water hemp, was we saw that increase of germination. So, are we seeing the seed bank depletion? 2% water hemp germination increase per pound of nitrogen. So could we, although we weren't seeing really increased control with that dual, could we really just be placing nitrogen at high enough rates to stimulate these weeds to germinate and then have some sort of, follow-up or post or, have that pre-clean up some of these and really just deplete that soil seed bank? I think that is the next question I really want to look at is how does this increase the soil seed bank? Because again, weed seeds are what make our weed management problems never go away, right? Something like water hemp, if it survives, it can produce tens of thousands of seeds. So that those tens of thousands of seeds are next year's problem. But if we can effectively get those all to germinate and manage them, the amount of seeds that we got to deal with in the future is going to go down low. We do need to have this effective weed management plan. We did look at, the germination, the post-emergence control, and the yield. And what we saw was, the nitrogen may not have been clearly helping, but that pre-post system is really what we need to do, right? We saw increased control with the pre and post compared to just the nitrogen only with the Liberty. And then also, there was really no benefit of nitrogen with the yield with the nitrogen. So, we need to have these effective weed management plan, not just try to rely on one tool. Now, this is probably not a whole farm treatment. When I've talked with farmers, consultants, colleagues, I even said it in the beginning. Farming's expensive. UAN is definitely not cheap. Especially since we did this in soybean, if we're not really seeing a yield increase, no one's going to put 50 pounds of N has UAN to be in the carrier. But again, could this be a site-specific treatment? Think about that seed bank depletion. With 50 pounds of nitrogen, we saw 200% increase of germination with water hemp. So just thinking about this site-specific management, could we, map our soil types or map our weed distributions to see, areas in our fields or farms where we might want to actually do this treatment, right? So a lot of the times weeds are going to follow, the distribution of weeds are going to follow some type of gradient. A lot of times it is a soil type. For instance, if you look at a field in central South Dakota where you have saline sodic areas, there's probably going to be more kochia there in the areas that don't have that. Wetter spots in the field may have more barnyard grass or Pennsylvania smartweed or cockleburr. These weeds are in certain parts of the field for a reason. And, when I think about weed management, again, and I think about it a lot because it's my career, I think about, my small plots and how we have this very even distribution of, for the example of this experiment of water hemp, right? And it's very easy to put the blinders on and say, yeah, we're always going to have weeds in this pocket, so the expectation is depicted by this cartoon on the left that has the title expectation. We have our green crop rows and then we have our light green weeds growing uniformly without, so we can just do, a blanket application of something, one size fits all, will have effective management. But the reality, again, depicted by this cartoon, the different colored little cartoon weeds can represent different weed species and their distribution is not going to be uniform. So again, if you think about this, applying UAN as a weed seed germination, maybe you're applying it where you have more weeds, trying to stimulate that weed seed bank so you can knock back that area. Whereas, if you have maybe an area that's drowned out or higher ground or area that just didn't have as many weed escapes last year, you probably don't need to put that treatment out there, right? Save that money because, again, farming's expensive now. All right, well, let's circle back to this graph again, looking at the how long of residual activity are we seeing. So we have, again, 80% control of 4 different group 15 herbicides ranging from 29 to 42 days after application. Again, this is 1 year, so it's not the end all be all, but again, 80% control. 20% of that herbicide's breaking. Now we're starting to have weeds in the field. We're going to have to spray something probably, right? So just kind of staying on the subject of the group 15 herbicides. Again, these are the very long chain fatty acid inhibiting herbicides. Things like Zidua, Dual Magnum, Harness, Outlook, Warrant, Inversa, Everprex, all those. This is what I'm going to focus on right now. So when we think about, the residual activity of these pre-emergence herbicides, I want to draw attention to this little figure where it says traditional soybean program. Now, this red triangle represents our residual herbicide activity. The star is when we spray a post, and then the green squiggly is when our crop canopy is. And the M through O is just the months of the growing season. So in May, if we're looking at our traditional soybean program, our residual herbicide beginning of May is great, but by the time, mid-June rolls around, it's vulnerable again, right? Think about back to that graph where we have 80% residual activity several weeks after application. Now, if we spray a post herbicide there and nothing else in there, so example, something that doesn't have any soil residual activity like Roundup or Liberty or Cobra, again, this is for soybean, we have this vulnerable period. Again, weeds don't just germinate with the crop. They're a problem because they have what we call discontinuous germination. So they'll have cycles where, and most of you have probably seen this, where you get a rain, flush of weeds. You spray them, and then let's say a couple weeks later, you get that half-inch rain, another flush of weeds. Now, this is important because if we don't have anything with residual activity, we have this vulnerable period. So this is after we spray the post-emergence herbicide and before crop canopy. So we're having weeds that are interfering with the crop. Perhaps some of these could be herbicide resistant. And even if it happens before or after, this critical period of weed control and we're not seeing a soybean yield loss, we're still having weeds that are interfering indirectly. So reducing harvest efficiency, seed production. Again, like I said before, the weed seed banks is what we really need to be focusing on for weed management, because the less seeds that are input into the soil, less of a problem we're going to have in the future years. So something that's been recommended more and more, and I think is a good thing, is, as we see above, is this layered residual soybean program. Again, setup very similar. You spray your pre-herbicide at planting, but with your post, you have a tank mix partner that has this residual activity. So instead of having this vulnerable period, you're controlling the weeds that are germinated, and you're putting a herbicide out there to control those later germinating weeds. And I think that's really important, because we can't really afford to spend the diesel fuel and the time to go back out and spray multiple post-emergence applications. I think the better bang for our buck is to try to minimize those weeds that germinate later, so we can have the crop do the work for us, right? So once we have soybean canopy, the crop's putting more competition on these weeds, starting to shade out those inner rows not favorable for weed germination. I'd like to just talk real briefly about how, these very long chain fatty acid inhibiting herbicides, or the group 15 herbicides, work. They're a little different than most of the herbicides we use. So what they do is, again, as the name states, they inhibit fatty acid synthesis. Now, just very briefly, this process is very critical for plant survival. These are precursors for cell membranes, leaf waxes, fats used for energy, and cuticles, right, to keep water in. So once that's stopped, especially in a small seedling that uses carbohydrates in the seed, it depletes that energy, and these weeds die, or plants die, actually. And it's important to realize too, if you've ever sprayed, something like Dual Magnum or Harness or Outlook, you're really targeting these smaller seeded weed species, not something like Velvet Leaf or Cocklebur. Not really great on kochia, or perhaps wild oat, or even woolly cupgrass, because again, weed seeds provide the energy to this weed seedling for several weeks before it even can conduct photosynthesis. So there's more energy in there. These plants aren't really relying on that fatty acid production. But it's important to mention too, I've said this earlier, that these type of pre-emergence herbicide kill the germinating seedling, and it doesn't cease germination. So these seedlings have to be germinating. If it came in contact with a dormant seed, it's not going to kill it. And these herbicides also have no post-emergent activity. If you've seen it ever sprayed on corn or soybeans, you get a little bit of plant malformation. Also, again, with the larger seeded species, they can emerge, but sometimes they come up with malformations. So an example would be the grass weed over here on the right, where it's buggy whipped, rolled up on itself. Again, that plant's not going to die, but it's injured. There's something obviously not going on right with it. These herbicides are also labeled for soybeans, but sometimes they can come up and have this drawstringing or heart-shaped look. Again, it's not detrimental, but obviously it's a malformation, right? Herbicide comes in contact, causes a little bit of damage. The other interesting thing I would say about these group 15 herbicides is they can be applied both pre and post emergence in a lot of different crops, a lot of these crops that we grow in South Dakota. According to the USDA, most of the time these herbicides are only applied once in a year, but depending on the rate and which herbicide you're spraying, a lot of these are labeled to be applied for multiple applications. So you could spray this herbicide pre-emergence and then post residual as well, and usually it's pretty safe. Now, if esbatolachlor or dual is probably the most common for soybean, whereas acetochlor or harness is the most common for corn. There's also a lot more overlap with acetochlor and soybeans and some of these other crops because there's microencapsulated formulations. So formulations such as Warrant or Inversa, what happens is that provides a protective coating. So you can now spray it on soybeans. Your soybeans can germinate and not come in contact with that herbicide. And then that polymer gets broken down and it kills the germinating weed seeds again. So something like Dual is readily plant available, and some of these encapsulated formulations are for crop safety, but it takes a little bit of time. You need more of that moisture to break that down for weed control. Now, there's a lot of research that's been done on this, and there's a reason why they're applied pre and post emergence, safely for crops, because there's been research. But, as we move forward, are we going to see more of these group 15 herbicides applied more commonly? Again, I don't think it's uncommon to see it pre, maybe post residual, but, as we move forward with herbicide resistance and input costs going up and always having a post residual in the tank, what's going to happen? So that was the objective of this experiment I want to talk about coming up. And this again is more soybean centric, but as we apply more of these group 15 herbicides, is there effect on yield under weed free conditions? If we look at it from, not spraying and spraying, well, you're obviously going to have a higher yield that has no weeds compared to, a field that's very weedy because it's being subjected to competition and interference. So in order to test this, we wanted to have the two group 15 herbicides. We used esbatolachlor in the form of dual magnum. We selected this one because, again, as I said earlier, this one's readily plant available. So there's no coating or polymer shell that's, acting as a physical barrier between the herbicide and the plant as a post-emergence and that crop seed as well. And then we also used encapsulated acetochlor in the form of Warrant. Again, this polymer shell is inhibiting immediate contact with the germinating crop seed as well as the vegetation of our crop. Now, we applied this at 3 different timings. We also had a non-treated as well, but we applied each herbicide at pre-emergence, early post, which would have been about V2, V3 soybean, and mid-post, which was about B5, V6 soybean. And we factorially arranged all of these timings. Now, to demonstrate what a factorial arrangement means is we sprayed, we had a non-treated weed-free. We had our pre, early post, mid-post, and then we had combinations of this. So we had pre-emergence followed by early post-emergence, pre followed by mid-post-emergence, early post followed by mid-post, and then all 3 combinations. And we did this with both herbicides. So it was a really big study and pretty intensive spraying. But again, we wanted to see what happened to our crop, because as you spray more and more herbicides, right? Think about that injury. While, you may not see that, a significant damage with a pre-emergence with that little bit of malformation. But what happens when you start putting these on, 3 applications of these different herbicides? Excuse me. Now, moving on to the agronomic details. So this was actually conducted at 2 different states. So probably more pertinent to us in this setting, we had 2 sites in South Dakota, one at Volga, one at South Shore, using locally adapted soybean varieties. And we also had a site in North Carolina. And you may be thinking, well, that's not pertinent. But again, we're trying to see, under different environmental conditions, for example, maybe a little bit more dry up here in South Dakota. Down in North Carolina, it might be a little warmer, a little wetter. So under all these different environmental conditions, that's what we're trying to see. Not just, for the semi-arid or, when it's really wet. We want to see what happens under, a whole playing field of these. Now, to keep them weed free, what we did was we applied Roundup or glyphosate and mixed with Liberty or glufosinate at the entirety of the study between the early post and mid post timing. Again, we don't want to have any confounding results based on weed interference. Kind of having said that, weed control was not the focus of the study. But we did want what we call that activating rain. Again, that activating rain is precipitation that moves that herbicide after being sprayed down into that soil profile where these weed seeds are germinating. Because if you don't have that, herbicide stays on the soil surface, weed seeds germinate right through it. For the most part, we're looking for about a 1/2 to 1 inch, pretty immediate, a couple days after application. For the most part, at all three of these sites, we're seeing some rainfall. There's some instances where we had a 1/4 inch, being on the lighter side, or we also had a few spots, at our South Shore site where we were having 2 inches of rain. At the North Carolina sites, we had a lot of rain, minimal rain, a lot of rain. But for the most part, at least 1 week after each application, we're having rainfall. So we're at least moving it through the soil profile. So the germinating seeds, crop seeds can come in contact with it, but also importantly at the mid-post, or the early and mid-post application, we're having it move into the soil profile. So it's not just a foliar contact, but it's also getting taken up by the roots. So what we did at the end of the season was we harvested our soybeans at each site, and we weren't looking at this in terms of bushels per acre because there's a lot of environmental factors that go in it. So what we did was we just converted it into relative yield. So it was the yield of our treated plot divided by the yield of the weed-free plot. And again, with this weed-free plot, this had no group 15 herbicide applied on it. This was just the plots that were treated with Roundup and Liberty. Again, we did an analysis just to see if the means of each of these different treatments were different from each other. And lastly, again, we're not really looking for the most part of the different environmental conditions. We want to capture that, but we also considered the location as a random effect. So we could pool all of our data together and say, across a broad region, when you apply these herbicides at the different timing, this is the result you can expect. So moving on to results. So just to set up this graph real quick, we have on our x-axis or the horizontal axis, we have S-metolachlor or dual and acetochlor warrant. On our horizontal or y-axis, we have yield. Again, that's the relative yield percent of our weed-free plots. Now, across all of our application timings for both dual and warrant, we see there's no difference between these herbicides. And for the most part, we're having about 95% relative yield of our weed-free non-treated plots. So, what this tells us is for the most part, these two herbicides aren't having a adverse or negative effect on our soybean yield. Now let's break this down into timing. So we're looking at all these different timings across both of our herbicides. So this graph's set up very similar, but now on our horizontal or x-axis, we have our different timings. Again, we have our singular applications denoted by the blue, 2 applications denoted by yellow, and then our 3-way, heavy mixture is denoted by the gray. Now you'll also notice that there's these letters above each bar. And what our analysis did was if bars share similar letters, they're not different. Okay, so for the most part, we're seeing a lot of A, B, A, B, A, B. So what this tells us is our yield, our relative yield is not different from any treatment. However, we did see a difference between plots in this experiment that were treated only at the post timing compared to plots that were treated at the pre followed by mid post timing. Now let's look at, the big factorial of all of this. So this graph is now set up again with just the different application timings on our X or horizontal axis, but now we have two different bars. So green is going to be dual magnum and red's going to be that warrant. And what we see again, there's no letters on this graph because the relative yield of these were not any different. So what this tells us, again, we're looking at anywhere from 90 to over 100% of our relative yield compared to our non-treated weed-free. So what can we really gather from this? What we can conclude is these two tested group 15 herbicides and application timings don't adversely affect soybean yield. That's parallel with the previous research, but a lot of that research didn't really, focus in on, as intensive application timings. Now, I do want to point out that early post timing, if we think back to just looking at the application timings across both herbicides, we saw that there was a lower relative yield compared to the pre followed by mid post emergence application timing. Now, I don't think that's actually a function of the herbicide causing this yield decrease, because it's the start of the critical period of weed control, right? We need to control weeds at a certain time period because once they start interfering with the crop, we start seeing the yield loss. And now the critical period of weed control in soybean is from V2 to R1 soybean stage. Recall, we sprayed these early post-emergence timings at about V2, V3. So we're starting to manage our weeds at that beginning of the critical period. And we also didn't apply the Roundup or Liberty until about, in between our E-post and mid-post timing. So that's probably why we saw that yield decrease. Lastly, these data are really important because, again, we're probably going to see more than one application of a residual herbicide, likely of the group 15s, because it's not going to be effective to just spray a pre and a post-emergence herbicide without any residual activity. But, in this experiment, we saw a whole slew of different application timing, anywhere from one application up to 3 applications. Now, I'm going to recommend applying these group 15 herbicides recurrently in a season, more than one application of the same herbicide with caution. There are weeds that are resistant to these herbicides. So again, if we think about how resistance occurs, we spray the same herbicide over and over again to kind of, excuse me, we don't really think about a lot of resistance with pre's, but it happens, right? So here we have a cartoon depicting how resistance happens. So for example, we take let's call this little square on your left-hand side of the screen a section. Let's just pretend that there's 100 weeds in this section. 99 of them are susceptible. One of them is resistance just by natural causes, right? Plants mutate. They have some sort of mutation where the weed can survive that herbicide dose. So if we're spraying, for example, and I'm not picking on any herbicides, but we spray dual 3 times a year, we can spray it in, corn and soybeans. So we're spraying dual 3 times a year in our soy. We rotate to our corn. We're doing the exact same thing. Well, as we do that, what we're doing is we're purifying this weed community. So when it was predominantly susceptible, we're killing all of those susceptible weeds and leaving the resistant weeds. So what happens then is those weeds survive, produce seeds. Again, there's this continuing theme of the weed seed banks, right? If we have weeds survive, produce seeds, especially if they're resistant, right? That resistance trait is passed down to the offspring. And over time, what we're doing is we're really, purifying this to be resistant. So that's why we really need to be careful with applying the same herbicide over and over again, even with pre's. Now, one way we can do this, and it doesn't matter if it's pre or post, but we can apply different herbicides, multiple herbicide groups in each application to kind of combat this. So for example, let's say we're going to tank mix herbicide as depicted by these jugs on the left. We have herbicide A and herbicide C. And let's say in this particular field, we have 3 different weeds or different weed biotypes that are resistant to 3 different herbicides. So if we're spraying herbicide A and C, well, if we just were to spray herbicide A, let's say we have weeds resistant to herbicide A, those are going to be the ones that survive. If we just spray herbicide C, well, we're going to have all those biotypes resistant to herbicide C survive. Now, if we sprayed it, the weeds that are resistant to herbicide B, well, those would get killed. But again, we're still having a problem. But what happens when we mix herbicide A and C? Again, we will kill weeds resistant to herbicide A with herbicide C. Using A and C together, it's going to kill weeds resistant to herbicide B. And then that herbicide A, will also kill weeds resistant to herbicide C. So the end goal of that is, rather than having, weeds that survive, hopefully we're not having any weeds survive. And again, we're looking at that in the case of resistance, but there's also a big value in using multiple herbicide groups because we can increase our spectrum of control. Now let's just think back to that earlier statement I made about the group 15 herbicide, right? They're more effective on smaller seeded weeds. So if we were just to spray dual magnum, we may have an increase of larger seeded weeds. And the same goes for if we just sprayed a herbicide that's effective on larger seeded weeds, but not smaller seeded weeds or perhaps grass weeds. Well, then we're just going to have more grass weeds, right? So here we have a graph kind of depicting this. And this is data from this 2024 growing season with green foxtail and velvet leaf. So on the x-axis of the horizontal, we have Mahler or metribuzin, dual magnum, S-metolachlor, and tendovo. So that has metribuzin, dual, and another herbicide called first rate. And then we also are looking at our percent control. Well, if we were just to spray the metribuzin, which is effective on velvet leaf, we're really missing some of that green foxtail. We're only getting about 75% control. Well, if we spray dual magnum to control that green foxtail, we're really taking care of our foxtail. But again, we're getting pretty poor velvet leaf control. But when we mix them, we can see our controls, approaching that almost 100%. About that 95%. So it's quite effective. Again, this is why we need to use the multiple herbicide groups, not just for resistance management's sake, but also just to be effective. Now, I want to just briefly end this up on, what I think are some of the currently overused strategies, this selection cycle. And I think we're really overusing the PPO herbicides here in South Dakota. And for a good reason. I mean, they're effective, right? We're using a lot of sharpened applied burn down, especially in the central part of the state with kochia, no-till. Also in the central part of the state, I think there's just a lot of fall applied valor. Again, it makes sense. We don't have a lot of precipitation, so we're using that snow melt in the more dry areas of the state. There's minimal crop rotation restrictions, and it's really good on kochia, right? And not as much, but we are having some post-emergence use too. Some places where we're using FlexStar, is that the best option with that low use rate? It's not as effective. And then we're also, we're using Cobra and something like Blazer in some of these rate restricted areas. But, I'm worried about this for a good reason, because up in North Dakota, they were doing this, a lot of sharpen, a lot of aim for burn down, a lot of fall applied valor, a lot of PPO herbicides used in, we don't really grow as much here, but a lot of their lentil and dry bean productions. And now they have PPO herbicide resistant kochia, these herbicides they were spraying to manage this. And it happened just due to that overuse. Think back to that cartoon. It starts out susceptible. There's a few resistant plants, and we do this over and over again. It results in resistance. I talked to Dr. Brian Jenks and Joe Eichley up at North Dakota State, and it's widespread in North Dakota. I mean, it moves around, right? We've seen kochia as the tumbleweed, it breaks off, spread seeds all over. So once you have this problem, it can really move around quick. And what they're also telling me is, we haven't, knock on wood, seen it in South Dakota yet, but they're suspecting it in Montana and South Dakota. Again, these seeds move. We're doing similar practices down here in South Dakota. And so I also asked Dr. Jenks and Dr. Eichley to send some pictures to me so I can kind of, just demonstrate or visualize this to you all on this webinar today. This is a problem. So for example, here we have sharpen at the 1 ounce and 2 ounce rate, 13 days after treatment on, pretty small kochia, 2 to 2.5 inches. So if we look at the left where it says susceptible, then we have 4 different populations from different parts of the state. On the bottom of the screen, that's sharpen at 1 ounce. Up top is sharpen at 2 ounces. These kochia plants aren't dying. We can see the susceptible are lit up about 2 weeks after treatment, but those resistance are doing just fine. And again, think about what I've been harping on, that the weed seed bank. If those aren't effectively managed, they produce seeds, they tumble all around, this problem stays or remains and, kind of blows up. They saw something very similar with AIM. They have their susceptible on the bottom and then Minot up top. Starts at the 1x rate and goes up to 16 ounces, right? That's 16 times more than we can spray. And those are looking good. Kind of going back on that fall applied Valor. Again, I think it's great. It's an effective application, but are we really doing ourselves any favor just putting out Valor in the fall? So to set this up, we have our non-treateds and our different susceptibles on the top and bottom, and we have our 2 resistance. So it's cross-resistant to not just the post-emergence, but our soil applied stuff, Valor. Now, we see that they're surviving Valor. They're susceptible to Zidua, and we know, and if you do not know, Valor, Zidua or pyroxasulfones, not super effective on these kochia plants. But it's adding effectiveness. And if we think about, using these multiple herbicide groups, when there was Fierce, that's Valor and Zidua applied together, look how much better that control is. Again, that's not going to be the end all be all, but, think about it. We need to add other things to the tank than just Valor. And you may be thinking, on the I-29 corridor, thinking, well, kochia is not a problem here. Well, this happens in water hemp too. So this is some research I did before I came to South Dakota State, but I was looking at some herbicide resistant water hemp. This is water hemp sprayed with FlexStar at what I would like to call real rates. On the left, that was sprayed with a pint, 16 fluid ounces. Again, those are going to survive. On the right, that was sprayed with a quart, 32 fluid ounces. Again, we don't want to ever do that here, because we would never be able to grow corn for several years. But again, this is a real problem. We really need to be conscious about what we're doing and what some of these mixtures are doing. Kind of a spiel for myself, I would really appreciate you all if you report these control failures. This isn't going to go blow up that Frank the farmer in Gettysburg, not picking on Gettysburg, but, has resistant weeds. No, this is just to let us know what's going on in the state, because if you don't report it, we don't know what's going on, and it's harder for us to make recommendations and let people know what to expect, right? Because again, think about it, these weed seeds move, whether it be, just by wind or, just animals, whatever. If we don't take care of these problems, it's going to blow up, and then we're really going to be losing effective herbicides across the state. So I would really appreciate if you report these control failures to, South Dakota State University Extension. Even if you report it to your crop consultant. I've had a few crop consultants reach out to me about herbicide resistance. And, even if you want to talk to the agrochemical companies, I know Dr. Eichley and Dr. Jenks worked with BASF with some of that sharpen resistant kochia, and, they came up with some ways to detect it, and they're starting to reduce, come out with some management plans. But just to wrap this up, something we can do to add horsepower to our weed management plan, some soil applied nitrogen can work. It may not be a whole farm treatment, but it could be a spot where we need to deplete that soil seed bank. Multiple applications of these group 15 herbicides do not negatively affect soybean yield. So if we're going to use them multiple times in a season, it should be fine. But again, avoid the reliance on these herbicides, right? Use different herbicide groups, stuff outside of the nozzle. Anything we can do for weed management, it's going to be a plus. And again, reliance on the PPO and herbicide the PPO inhibiting herbicides, Sharpen, AIM, Flexstar, Cobra, Valor, Spartan. There has been resistance up in North Dakota. I think we really need to be cautious about what we're doing moving forward. I'd also like to thank the South Dakota Soybean Research and Promotion Council. They funded a lot of my research. And with that, I'm going to open this up to questions. So we have a question. Do you have a comparison to the nitrogen only and nitrogen pre that is pre only? I would think that the control. So we did have just the pre, and we didn't really see, I guess if I'm answering this question correctly, that control wasn't influenced by the nitrogen. But what my next question would be is, just visually, we took a germination count. So we took a little square, threw them out there 3 weeks after treatment. And what we saw was, just the dual compared to, 5 pounds, 10 pounds, 2550 there was no difference. So what's curious to me though is, again, I said it looks like the control's the same, but we're killing the germinating seedlings. So what I'd really like to do this summer is kind of do a replication of this experiment, but look at soil cores and see if the weed seed bank is different. So they say, did you assess pre only versus end press? Yes, so that's I kind of elucidated that we did just do a straight pre with no nitrogen. And again, just visually looking at weed counts, the same amount of weeds germinated for the most part between dual only and then dual with the different nitrogen rates. And yeah, it doesn't look like it's really boosting the performance of the pre to the eye, but I think we need to get, under that visual surface with the but that's kind of where we're at with that. So the one last question we have was, did you look at the effectiveness between nitrogen pre and water pre? Yeah, so what we did was we did have the pre only again, and we did use that with just water. So, for the most part with like 5 pounds, that wasn't enough UAN to make it the mixture we needed. So we added water to that as well. I don't see any more questions coming in, so we'll leave this up for a little while longer so you guys can get all of your CCA credits in. I do appreciate everyone in attendance. I really do appreciate it. I guess just while everyone's still on and hanging out, oh, here we go. Would there be any other fall applications for kochia? So that's a really good question, and I've talked with a lot of people, because if we think about it, there's really not that much, but I think there's still options. It's not going to be as ironclad as the fall applied valor, but the fierce. So the Valor plus Zidua, from my understanding, that's looking really good, for the most part. Anything like Prowl, again, and some of you may be taken back by this, but uh it's not the best, but again, it's something else. And again, that little bit of control is good. The other thing I think, and I didn't mention it here, I do think we shouldn't just rely on the fall applied. And it gets tough because as we move towards the center of the state where it's a little bit of drier, in the no-till where we really rely on that snow melt. But if we can apply, and it could even be a cheaper, if you will, but just a spring pre as well. I think there's a lot of utility in that. Even if it is something like a dual, or whether it be a early pre-plant prowl or a Zidua. I don't think we should do a Valor followed by a Spartan. And if you're going to corn, you have your HPPD, something like Balance or Callisto, which are okay. I think there's some utility in that as well. But if we can mix other things with the Valor, I'm not saying Valor needs to disappear, but it definitely needs to be mixed with something, because I think we're going to find ourselves in trouble if we don't. But well, everyone, again, I really do appreciate you all joining. It's a lot of fun. I really like presenting some of this off the wall research, especially with the soil applied nitrogen and soybean. But again, I really do appreciate it. And we will catch you all tomorrow, hopefully. Stephen Robertson will be talking about the Endangered Species Act mitigation. And I think that's going to be a very good talk, because, even being, a weed scientist myself, it confuses me. So I think that'll be a good time. And then we'll see you also on Thursday for some more weed talk. I really appreciate you guys coming in. Thanks.